Artificial intelligence has become so hungry for computing power that tech giants are now chasing a wild idea: move the data centers off the planet entirely into orbit. And in 2026, this stopped being science fiction. Real companies started filing real plans to put thousands of computers in space. So why on earth would anyone send a data center to the stars? It starts with a problem here on the ground. Every AI request you make runs in a data center, a giant warehouse of computers that devours electricity and water for cooling. As AI explodes, these centers are straining power grids, and there simply isn't enough land, energy, and water to build all the computing the world suddenly wants. Space offers a tempting escape. In orbit, the sun never sets behind the horizon and is never blocked by clouds or weather. A solar panel up there can soak up powerful, uninterrupted sunlight almost around the clock, generating clean energy far more efficiently than one on the ground. Free, nearly limitless power, just waiting to be tapped. That promise has triggered a gold rush. SpaceX has filed plans for up to 1 million computing satellites. Google has a moonshot called Project Suncatcher, aiming to launch its AI chips into orbit on solar-powered craft. And a startup named Starcloud became a billion-dollar company almost overnight, purely on the dream of building data centers in space. So how would an orbital data center actually work? Picture enormous wings of solar panels feeding power to racks of AI chips, all flying in formation. Instead of cables, the satellites would talk to each other and to the ground using beams of laser light, knitting the whole swarm together into a single, giant supercomputer orbiting the Earth. But space is brutally unforgiving, and the first great challenge is heat. Computers generate enormous warmth, and on Earth we blow air or pump water to cool them. In the vacuum of space, there is no air at all, so the only way to shed heat is to radiate it away. That demands vast radiator panels, sometimes larger than the computers themselves. The second challenge is radiation. Beyond our atmosphere's shield, a storm of cosmic rays and solar particles constantly bombards electronics, flipping bits and damaging delicate chips. The very first thing Google plans to test in orbit is brutally simple. Will its AI processors even survive the sun's radiation long enough to be useful? So why is this happening right now? Because the price of reaching space has collapsed. Reusable rockets have made launching cargo dramatically cheaper than ever before. Suddenly, the math changes. For power-hungry AI, it may soon be competitive to launch a data center into orbit rather than fight for land, water, and electricity back on Earth. Still, the obstacles are real. A broken computer in orbit is almost impossible to repair. Space junk threatens any large structure, and nothing on this scale has ever been proven to work. For now, these are early prototypes and bold filings, not finished factories in the sky. The dream is racing ahead of the reality. Yet the race has truly begun, transforming a far-fetched idea into one of the hardest frontiers in technology. The cloud that powers our digital lives may quite literally be heading for the sky. Whether it succeeds or not, it shows just how far we'll go to feed our hunger for computing. And if there's a science or tech topic you want explored next, tell me in the comments. Your question could be the next video. If this made you a little more curious about the world, subscribe to the Binary Brew, and I'll see you in the next one.